Hi friends, welcome to Machine Learning Journey. This is lecture 5 of ML series. In this lecture, we will understand types of supervised learning, classification, regression. In this lecture, we will also understand how to identify whether a problem is a classification or regression or something else. So we will identify what kind of problem it is. So starting with classification, for example, in the any ML system you're trying to build, so you have a data and you are trying to build some model with this data so that it can understand the data patterns and it can predict your expected results on generic data. So in the supervised learning, I discussed in the previous lecture that supervised learning means in the data itself you have input output pair, that is x corresponding to y. You have x is the input features and y is the output label, so you both you have. Now now you want to figure out of this supervised learning which kind of problem statement we are trying to solve, whether it is a classification or regression. So to identify that is because to identify the type of problem is necessary to decide the next loss functions and some internal functions also we need to assign to hidden layers, which is activation function. So that needs to be identified. For that, you need to understand about the labels, how the label looks like. So if the labels are category, then it is a classification problem. What do you mean by category is, let's say you have a problem statement of knowing the email is a spam or not. Then here clearly you have two categories, spam and not spam. Let's say spam you identify as a 1 and spam is a not 0. So it is a classification problem. Now let's say you have a one problem statement of predicting the price of a house. Given input is location, bedrooms, city. Inside city location is there. So if there are given input features, what is the output or price of that particular house? So for that the output will be some numbers like a 85,000 dollars, something like that. So the output is numbers. So when the number is a output in your input output pair, the data, then it is a regression problem. So uh, always keep in mind, whenever the problem statement says that the prediction is a category, then it is a classification problem. And whenever the prediction is number, then it is a regression problem. Let's say you have a few parameters of a city or area about humidity and weather, climate, location, and you want to know the temperature of that city. So or maybe you have a temperature, you want to know humidity. So this temperature, humidity, these are the continuous values and it is represented by numbers. So it is a regression problem. So likewise, you can identify whether a classification problem it is or whether it is a regression problems. So with that, like I have explained about classification regression in a supervised learning. Now in like in a recommendation system also, the learning is different. Recommendation systems are based on many types of learning. I already explained in unsupervised learning, it groups the data or videos in some groups and then it recommends you on the basis of reinforcement learning the kind of feedback you give. In the feedback itself, for each video, model predicts whether you will like it or dislike it. So that a small portion of movement for one particular video, that is also a classification problem for the complete recommendation system. Small part of that system is a classification problems. So likewise, you can identify the output. Output is a category, then it is a classification. If it is a numbers, then it is a regression. Now coming to classification. Now on the basis of number of categories you have to predict, it can also be classified into, it can be also be two types. One is binary classification and one is multi-class classification. So in the binary classification, the output label contains two categories only. Output labels contains two categories, 0 and 1. Let's say 0 is a spam or disease present, not spam, or disease not present. So likewise, whenever the output is binary, is it 0 or 1? There are only two possibilities, yes or no. Then it is a binary classification problem. Multi-class classification, when there are different classes to predict or categories to predict or different labels to predict. For example, you have an image and you have trained one model to predict which animal it is. So you may have trained for 10 animals, let's say cat, dog, cow, so etc. You have 10 animals, so that is 10, which is if it is more than 2, then it is a multi-class classification, but it involves multiple labels to predict or multiple class to predict. Why this differentiation is necessary? Again, for the loss functions, we need to identify whether it is binary classification, multi-class classification. We will understand in the loss function lecture how it varies, but as of now you just understand that in the types of supervised learning there can be two types, classification and regression. Classification is based on the category, regression is based on the numbers. Inside classification inside classification also there are two types, binary classification and multi-class classification. Binary classification outputs two labels, 0 or 1. Let's say 0 is represented by with your data, according to your data spam is 0 and not spam is 1. So output is only 2. This is present, this is absent, like this. Let's say if you have only two animals to predict in the image classification, then it is a binary classification because you're trying to differentiate between cat and dog only. But if you involve 10 animals or maybe 100 animals, then it is a multi-class classification because the prediction, the number of classes increased. So that is why it is a multi-class classifications. So thanks a lot. Thanks for listening. We'll meet in the next lecture.